This is our first lesson where we're actually going to be solving these quadratics. So we kind of did this with graphing, right? Do you remember what solutions are when we graph our equation? What are the solutions on my graph? They had a bunch of different names. The solutions.
Zeros, and then what was the other one?
X-intercepts. Roots, zeros, and x-intercepts.
Good job, Jez.
Those names are what we say is the X-intercept.
So solutions are here on my graph. They're where my graph crosses the x-axis. So in this picture, I have two of them, and they are approximately at x equals negative 1.7 and maybe positive 1.7. We're kind of eyeballing it there. Question?
Are you making us do homework?
No.
I literally just asked that.
Why are these solutions difficult to identify? Because they're not on exact coordinates. They are not whole numbers.
I take all the blame. That's what you say. It's a quote. Make Will.
Okay. So, when we talk about solutions to quadratic equations, we're talking about their x-intercepts. We can do that using graphing, but graphing is not the only method that we use to solve. We can also use three other methods. The first one, the easiest one that we're going to learn today, is called square roots. By far, square roots is the easiest of the three methods we're going to learn. However, it does have some restrictions. This method can only be used when there is no bx term. That means if I'm looking at my equation in standard form, which is usually ax squared plus bx plus c, we are not going to have that middle term. You will have the x squared term and you will have the constant term, but you will not have the term that just has an x. If you do, we cannot use this method. Is that clear? Do we know what square roots are? We've talked about them kind of before. Square root is when you multiply something by itself, you get a number. So the square root of a number is the two things that multiply together, right? So if I look at 16, what's the square root of 16? 4. However, we have a second option. Do we see how in this graph it crosses the x-axis twice? That means we will have two solutions, mostly, not every time, but mostly we will have two solutions. So when I square root something, I can have 4 times 4. What else would get me 16? Jaden. Yes. So we have 4 times 4 gets me 16, and negative 4 times negative 4 also gets me positive 16. So when we write these, we need this symbol that means plus or minus. So it's like a plus sign on top of a minus sign. And we need that every time we do square roots. What about 81? What's the square root of 81? So the square root of 81 is 9, but we want plus or minus 9. Does 10 have perfect square factors? So this is where we're going to put this into our calculator. And if you don't know how to use the calculator, I'm going to show you right now. Mine's a little weird. So for most of your calculators, you're going to have to hit second. And then this x squared button right here. It's got the little square root on top of it. And then I'm going to type in 10. Now when you hit enter, you should get the decimal you should get the decimal. I have to hit an extra button. No worries. There's my extra button right there. So the square root of 10 is 3.162. We're going to round that to 2 decimal places. So 3.16 is all I need. But then I don't want to forget this is plus or minus 3.16. Okay, let's keep going. Can we rapid fire through these? Does D have a perfect square? So what's the square root of D? Of 8? 2.83, we want plus or minus. What about 121? This does have perfect square factors. It's plus or minus 11. And then what about for 30? Does it have perfect square factors? So again, let's put that into our calculator. I can do that really quickly. Right here. Square root of 30. Hit enter. 5.47. We're rounding that up to 5.48. Plus or minus. Questions on this part? That's the easy part. Okay, flip it over. So now, do you see all of these equations? These are all quadratics, but these are all quadratic binomials, not trinomials, because every single one of them is missing that x term. There are no just normal x's in here. It's either x squared or it's a constant for all of these. We have to keep that in mind because otherwise we cannot use this method. This whole page, no bx terms. To solve, it's very straightforward. We're going to isolate the variable, get it by itself on one side, and to do that, we're going to use reverse PEMDAS, so reverse order of operations, starting with addition and subtraction and working our way backwards, right? Like the railroad method, we've done this many times before. I split it down the equal sign. I'm going to add 75 to both sides. This is 3x squared equals 75. I'm going to divide both sides by 3. X squared equals 25. And then once that variable is isolated, to get rid of the square, we square root both sides. So I'm going to do the square root of this side, the square root of this side. X squared, the square root, cancels out. It goes away. It's just x. And then on the right side, the square root of 25 is not just 5. We need plus or minus 5. And now we're going to sketch it. So I'm going to go ahead and put my points on -5 and 5, and I'm going to draw my parabola through because I know that when I solve, when I get solutions, those are x-intercepts. Any questions on that? Okay. B, pretty easy here. I only have one step to do, right? I only have to add 35 to this. Does 35 have a perfect square factor? No, doesn't have a perfect square. So I'm going to square root both sides, but I'm going to get plus or minus some decimal. It's going to be like 5 point something. So let's plug it in. The square root of 35 is about 5.916. I'm going to round up to 5.92. And then I do not want to forget that plus or minus there. And then again, we're going to put our points on here. This is -5.92 and positive 5.92. And draw a parabola. Good? Okay, things start to get a little bit weird, so let's pay attention here. Maybe not this one. Let's move this 15 over. Let's add 15 to both sides. 5d squared equals 45. D squared equals 9. Does 9 have a perfect square factor? It's 3. So we have d equals plus or minus 3. There's -3. There's +3. It goes through both. Okay. Take a look at D. We're going to start this the same way, and then something weird's going to happen. So I'm going to move everything to one side. 4d squared equals -4. I'm going to divide both sides by 4. D squared equals -1. Does anybody see the problem yet? When I square root this, what's my problem? Not the 1. The square root of 1 is 1. It's the square root of a negative number. That's my problem here. So, I need you to think about this. When I want to get a positive number, I can multiply a positive times a positive or a negative times a negative. If I want to multiply to a negative number, what do I have to multiply, Chaz? A positive and a negative. So the only way to get to negative 1 is to do 1 times negative 1. Are those perfect square factors if they're two different values? No. So my rule is after I have isolated my variable, this d squared has to be by itself first. So after the variable is isolated, if the other side is negative, then what do we think we write? It's no solution.
No solution.
There you go.
Thanks.
That first part of this rule is super important. We cannot skip the isolating of the variable. I'm going to show you why in a second. That variable has to be by itself before we can say no solution. What do we think the graph of this looks like? Can we graph this? What is it? It's still going to be a parabola shape. But if it's no solution, that means it's not going to touch my x-axis. So it could look something like this. That's a parabola that doesn't touch the x-axis. That's no solution. Because remember, those solutions are x-intercepts. Everybody good on that? All right, so let's do another one. We're isolating this variable. It is no solution too because I've isolated that x squared, and now 10 is negative. Thank you, I got it. The notes packets are on the back table. Okay, so again, no solution. And my graph looks like this, where it doesn't cross the x-axis. Good there? Okay, look at F. I want you to change this first number to negative 2. Put a negative in the front. Just see what happens. Okay. So, the reason we have to isolate this variable all the way is because this first step where you're doing addition or subtraction might not be telling the whole truth. When I just do that first step, I get a positive 14. However, when I keep going, the number might end up changing. So if it's negative right now, it could become positive. Or if it's positive right now, look what happens when I divide this by a negative 2. All of a sudden, I'm looking at a negative number. So we have to simplify this all the way before we can say no solution. Please don't skip simplifying it all the way. Any questions on this? We got it?